Now this slide, we say our forefather, Dr. Vikram Sarabhai, he said, we means the nation must be second to none in the application of advanced technology to the real problem of man and society. So we started the rocketry program from, as earlier speakers told you, from Mandalin Church, from Tumba, Thiruvananthapuram, and then we have developed our rocket starting from the sounding rocket, went for the SLV3, augmented with ASLV, PSLV. I think our earlier speakers, they have given in detail, so I will go ahead. Now start the history of rocket technology. So when we talk about, मैं जब बात करता हूँ ना लॉन्च पैड की और लॉन्च व्हीकल की और रॉकेट के बारे में, तो हमारा ध्यान कहाँ जाता है? We go towards the memory of the Diwali rocket. You know what is Diwali rocket? You put in a bottle, put a rocket that ignite with the help of a matchstick. So bottle is nothing but launch pad, and rocket is what? A launch vehicle. So in Sriharikota, what we do, we have a launch pad. Like a bottle, we have a big launchers. And then we have a rocket, sounding rockets, ASLV, PSLV, and GSLV. So I thought I will briefly just try to explain about a brief history of the rocket. This is the first rocket which is used in the year of 1232. Then used by the Tipu Sultan, it is called the Mysorean rocket. And whatever they use the gunpowder, is the combination of oxidizer and the fuel. Then which is the word first rocket, which is used by the Goddard. He is called the father of the rocketry in the world. He has first launch he has made in March 16, 1926, using this rocket. Of course, it did not take off from the launcher because of thrust and the weight ratio. Then the first rocket is called the V2 rocket or Vigilance V.2. The next rocket was called the Sputnik. Somebody asked in the chat box question, when was the first satellite was launched? So I don't remember his name. For him, the first artificial satellite is launched on the 4th October 1957. This is the pictorial view of that satellite having this antenna. Next was the US Explorer with the next satellite which was launched. So in the space race, US they defeated the USSR. Somebody is asked what is the full form of USSR. Earlier, this Russia was called the Soviet Union, and its full name was the USSR that time. After its bifurcation in '94, it is called now Russia. Then this is the first rocket launched by the US Explorer. This was the satellite or the which moved around the Earth of 225 miles. It's launched by a rocket, a giant rocket, very huge rocket called the Jupiter C rocket. And you can see the rocket is such a big one, and the small is the US Explorer, small payload, which is in the form of here I shown you. Then when first man went to space, somebody asked in the chat box a question. The answer is Yuri Gagarin on April 12, 1961. Then the first man landing on the moon, as all of us are aware, Neil Armstrong was the first man to put his leg on the moon on the July 16, 1969. Next was the first space shuttle, as all we know, it's called a Space Transportation System. 12th April 1981, it was launched for the first time. And somebody in the chat box asked why we have launched a satellite orbiter from USSR. In the year when this orbiter was made ready, in the year of 1977, we don't have that time the technology where we can put anything, any satellite in the orbit. That's why we went to the Russia, the spaceport from where they launched like Sriharikota. It's called Kapustin Yar, and it was launched from there using the rocket, some Ultracan. And in India's first mission to the moon was the Chandrayaan, As all of you know, we have launched from our GSLV rocket on the 22nd October 2008. Then we have launched our first Mars mission. Then we have attempt made for moon landing by the Chandrayaan 2. All of our students, all are well aware. It was launched 22nd July 2019, and when it was about to land on the 20th August 2020, 2019, all the eyes were on the, and this was seen more than the viewers who watches the T20 match or the cricket match or football match. The viewers for all over India was they were seen. I was doing the running commentary from one of the TV channels from Noida. That is, of course, we just missed it by a few meters from the surface of the moon. Now the question to all the students are, how it is possible? How we achieve all these things? How we send a satellite in the orbit? How to place a satellite in orbit? How to land on moon, Mars, and other celestial bodies? Because Japan JAXA, that agency, is expertise in landing their satellite on the asteroids. Then man living in ice. These are all things. How it is possible? Who did it and where it was done? This is called our experts were telling called igniting the mind of the students. So how it is happened? This is possible only when you have a launch pad, you have a launch satellite launch vehicles. Then only it is possible to launch it. So all of us, all of the students must be knowing that where is the launch pad in India. There are two types of launch pads are there. One is launched by the rocket, which goes to the atmosphere, do the measurements in the atmosphere, and fall back to the Bay of Bengal or the sea. Another launch pad is where we can put a satellite in the Earth orbit. So this type of launch pad is only one in India at the Sriharikota, and we have two more launch pads where we do the sounding rocket launching. One is the Tulls Tumba, and the second one is the rocket launching station Balasur. At present, it is not in function in the Balasur. Then, so we should, if we have a launch pad, then we should have a satellite launch vehicles. So how many launch vehicles we are knowing? I think all our students must be aware or must be knowing by heart how many satellite launch vehicles we are having. And earlier speaker also he has told in very detail each part of the rocket stages they explain. I will not go in that much detail. And sometimes we tell our launch pad of Sriharikota as the spaceport of India. So what is the requirement of a launch site? Can anybody can guess we can make a launch pad in the mid of the, say, Nagpur, or let us say most of people are from Uttarakhand, whether we can make a satellite launch station in the Uttarakhand? No. Because these are the launch vehicles, they are of 2 or 3 minimum stages to put the satellite in the orbit. So one launch, one stage is ignited or the function is over, it will fall back to the Earth. And the weight will be of the order about 20 tons to 30 tons of single piece. Wherever it will fall, it will make a big crater. So it is not possible to launch from any of the populated area except for the Russians who have a launch pad in the very barren land where their stages falls on the barren land. This is the only country in the world which having a launch pad on the where the stages falls on the land. Now let us see what is the requirement of a launch site. One is called when the launch azimuth corridor means when the rocket is launched, it goes in certain direction. That is called the corridor, and it is and its path. Each stages when they burn out, they will fall in a safe zone. That is in the Bay of Bengal. That is called stage impact. Similarly, it's called there should be a very large area where we can have freedom so that the stages can fall in a safe way. And that particular launch site should have a road transportation or the air transportation between the big cities. The Sriharikota is very near to Chennai. It has connected with the road, with the rail, as well as by the helicopter. Then we take the use or the earth rotation. As you know, when the earth rotates, we get the initial velocity to the order of about 452 meters per second. If we launch towards the east, we get the positive initial velocity. So this is a plus point. If you launch toward the west coast, you have to deduct this particular velocity and you will lose certain initial parameters. Then rocket should be tracked, should have one station, which will have a tracking station, which should have a telemetry. Then this launch vehicle is, as the earlier speakers have told you, it consists of so many stages. I also will tell in the subsequent slides. So we should have a place where we can join all the stages. That is called the servicing facility. Then when the satellite customer is coming to our launch pad, we should have a place where he can stay, where there should be place. So that is called the satellite customer service. We should have in a good one, in a large words. Now the azimuth corridor, as I told you, suppose this is rocket is launched in this direction. This is called the azimuth. Azimuth is the angle sustained by the flight with the north. So this is the angle when you take it, this will be called the azimuth angle. Normally, this will be of the order about 104 to 135 or 136. And this is called the large safety zone. So it means you have so much freedom in the Bay of Bengal, where you are free to drop your stages to different places here. And East Coast, we take the benefit for this rotation. You can see from here, when the rocket launched from here, the first stage is likely to fall in this square zone. The heat shield separates out after 100 kilometers, it falls here, the second stage. Like this, we make a very safe corridor. If you see in the global, the same thing is depicted on the in a global Earth globe. Then then where is located the Sriharikota? Most of our students must be aware where is the Sriharikota. As the name itself, Sriharikota looks like a name of Uttarakhand or the UP or MP because it doesn't mingle with the Andhra Pradesh names. So this is a very big story of this name. Okay, that we will skip. This particular island, the island, as you know, the place which is having all around the water. The Sriharikota is an island where three sides there is a Bay of Bengal, and the other side there is called a Pulicat Lake. It is a short lake. While going, we have to cross over the Pulicat Lake around 10 kilometers on the elevated platform here. This is located about 80 kilometers from Chennai, connected by the helipad road. The area of the island is only 175 square kilometers, and from end to end, that is called the coastline, is the order about 50 kilometers.
I
Then we
request
have
other
very
panelists. Hello, Srivastava. Yeah,
sir.
some voice I am listening, so other panelists can switch off their mic. Sir, some background noise I am listening, sir, please. Other panelists can switch off, please. Those who do.
Okay, thank you, sir. Now we comes to the pad, what's called the launch pad. We sometimes call as a launch facilities. We started the launching a rocket from sounding rocket. This is a abbreviation of SRC, sounding rocket complex. Sounding rocket is a rocket when it is launched in the atmosphere. It does the recording the data of the wind. It goes to the height depending on the stage of the rocket to the maximum about 560 to 600 kilometers. It takes around 7 to 8 minutes to ascend and same time to descend. In that time period only, it will do all the scientific and technical data. This sounding rocket is not capable of putting anything satellite or any payload in the satellite orbit. Then we comes to our first launch pad. The abbreviation is SLV, that is a satellite launch vehicle. So this you can see here is a satellite launch vehicle. It is assembled in a building, then it is transported on this trailer. You see the huge trailer. Then it transferred to a launcher. It is in the abbreviation we call as ITL, Integrate Transfer Launch Vehicle. This was the technique used by the project director, Kalam Saab. The first two launches was made under his project director. Next is called the ASLV, Augmented Satellite Launch Vehicle. In that, what was done? This rocket was the same. Yeah, our pioneers, they added in sideway 2 more rockets. They called the word used augmented. Means we can have more payload with the same technique, same knowledge here. Then we developed a rocket called PSLV, which is able to place the rocket in the polar orbit. This was made for the for polar satellite launchers. Then it was augmented to launch GS, that is the Geosynchronous Satellite Launch Vehicle. Now it has been decommissioned for the GSLV and further augmented for the small satellite launch vehicle called SSLV. Up to 500 kg of the satellites we can launch from the same launch pad where we are launching the PSLV. You can see a curved rail. A rocket will be made about 1 kilometer away from there. It will be transported on the rails and launch it. And the satellite, then this launcher is again ready. This is also called IETL concept, integrate, transfer, and the launch. But PSLV, when you launch here, it is it is integrated in this tower. So we cannot launch very frequently rocket here, but this method every 15 days we can launch here. This is the second launch pad, which is capable of launching all types of ISRO manufactured rocket. It may be PSLV, it may be GSLV Mark II, it may be GSLV Mark III. Any special rocket is made of the bigger diameter, all we can launch from the second launch pad. Now, if you see the first launch facility, I already described in there. This was commissioned in the 1993. Now, how PSLV rocket is made? When we talk about rocket, how it is made? Now, in the Sriharikota, we have a very huge production of the solid propellant plant, where we are manufacturing tons of solid propellant. Then second stage of this PSLV, it is done in our system concerns as Mangiri. It is transported from there. Third stage is again manufactured in Sriharikota at our plant. And the fourth stage, which is liquid propellant, it is again comes from Mangiri, our sister concerns IPRC. And all our earlier speakers, they have talked about the satellite and the heat shield. So now this particular first stage is consists of 5 segments. I think picture is clear. We can see 5 segments, 1, 2, 3. So this segment, each segment is weighing around 30 to 35 tons, including hardware. So it is very difficult to transfer this one. So each segment by segment is made. First segment is made. You can see here the 3 segments are there. When this first stage is ready, the second stage is brought here and then integrated with the first stage. You can see the third stage and the fourth stage together. Then finally the heat shield. So before heat shield is closed, the satellite is ready here. Then they go to the adapter. Earlier speaker, he was telling there is special type of adapter where we can mount 104 satellites or the dual satellite. This is the adapter what he was trying to show, but due to some inconvenience, this didn't open. This is all made of the carbon fiber and the shield. Inside there is a satellite. There is a satellite here. The satellites you can see from here. So like this, they are distributed. You see from here, one is distributed inside before closing. 1, 2, like this. They are all mounted on the satellite. And each satellite, sorry, each rocket, the second rocket I've shown you, this is the nozzle of the rocket. As you know, when you have to control the rocket, this nozzle on its axis is just to move left side or right side, or it can go as a circular also, depending on the usage in the flight, where we have to navigate inside in the atmosphere. When everything is ready, you can see from here, this big huge tower, it is moved. It is about 3,610 towers. It is base. It is kept on a trolley, just like a railway bogie, which is having about 32 wheels. Out of 32 wheels, half the wheels that are on 36 wheels, they are driven by hydraulically, and the satellite tower moves from the launcher to its extreme position about 118 meters. It takes around 2 hours to move from this to this side. We go to the next slide. Now you see when the rocket is launched, how it looks like. This is animation from the actual rocket. Now you see in this animation, which I stopped it. After the rocket takes off, there are the 4 strap-on rockets which
Sir,
were
your
fired.
animation is not visible, sir,
Oh.
on the screen. I think.
Okay, sir. Then I will skip that.
You're on this.
I will skip then.
Thank you. It's not running, so just only one window is open.
Okay, I will skip it.
Yeah, this is C32 Flight
Yeah.
profile.
Now, when the rocket is launched here, as I told you, you cannot launch from the center of India or from the land. You have to launch in such a place where the spent rocket, which are being used, should fall in a safe zone. In our case, it is the Bay of Bengal, but the Russians, they put in the land itself. That is because of their geographical condition. So here in this, we have shown you how the rocket goes, and somebody asks you the question, if you launch from here, how many minutes take to put the satellite in the orbit? So if you go through the slide, you will know the time. It depends from 14 minutes to 16 minutes, it will be able to put you in the orbit. It depends which orbit you want. It is a highly elliptical orbit or the GEO orbit. So this will take slightly less time because altitude is less. So PSLV is capable of putting satellite in both the orbits. Now this is the same thing when the rocket earlier, when its stages fall, this is a place where the strap-on rocket, I shown you the 4 strap-ons, they fall here. Then this is the place where it's likely to fall the first stage, then the heat shield, then the second stage, and finally third stage will go very far. This is another view of the PSLV when it is launched in the eastward direction for the GTO. The different places what I have shown you, these are probable impact points from the rocket. Now this rocket which has failed is recently launched here. All the debris has fall in this area, the second stage and third stage. So we have very constrained system here when placed here. Now let me go to explain to you about the second launch pad. The second launch pad, you can see here a huge building, and the concept used here is integrate, transfer, and launch. In this building, all the rockets will be integrated here on this rail, which is about a kilometer long. It is rocket is taken on the bogie and transferred to the launch pad. Then bogie comes back, and you can see here is the first launch pad with respect to the launcher. The distance between these two kept is very safe. We can launch if both the rockets are ready. We can keep in this place here. The safety distance has been matched from there. Then we have in the background, this is called a very huge test stand where we test the first stage around 200 tons of solid propellant. And these are the facilities where we have a servicing that the liquid propellant storage and we transfer through the pipeline to the rocket here. So this is the technology. This is the technique that we used here. We integrate in the second launch pad. Put the rocket on the launcher. And the bottom you can see it's the bogie. It takes to from building to the launcher, which is around a distance of about a kilometer. Then you transfer it to the launcher. Bogie comes back, and you can see rocket here. The GSLV rocket, how it is integrated? It is also integrated the same way as the PSLV. These are the segments. Each segment weighs a solid mass about 25 ton, and with the hardware, it will go up to 45 to 50 tons. So all the 5 segments are joined together and make first stage. Then we brought the step on, that is the L40 rockets. We join in the side, then brought the second stage, then the satellite. And before bringing the satellite, the earlier speaker they told it's called the deployment of the satellite. This facility also is in Sriharikota. The satellite panels are deployed, then again is stored back. Otherwise, they will not go inside the shield. This is the picture already they have shown you. I am also showing the same picture. Now this is animation. Whether you can see this one, sir, you can confirm. Jan sir.
Yes, yes, it is visible.
Now it is moving. Picture is moving.
It is moving.
Okay.
It is animated. Yes.
Okay. This is animation of GSLV. 4 rockets are fired at the same time. If there is a thrust difference, there will be shut off command, and the rocket will not take off. Now, after going altitude of about 50 kilometers, this will separate out from the second stage. You can see the separation. The interstage part, the heat shield opens when it crosses the atmosphere around 100 kilometers. Now you can see the third stage and the satellite separation. When satellite goes in the orbit, satellite has its own component which are deployed as per the requirement of the satellite. You can see this antenna. It is from NISAR. Synthetic aperture antenna is there. Now antenna is fully deployed. Now another video is there. This is for the Chandrayaan, where we could not able to achieve all the objectives. This is the Vikram trolley. When the all satellite is joined together.
Marvin, I'm still in the webinar. I will call you.
It's a launch from the Mark 3 rocket. This is a separation of the Chandrayaan. Now is the landing on the moon surface. These are the animations. And now you can see the Vikram is coming out from the satellite. This is for the second launch pad. You can see in the background 2 huge buildings where we can integrate the rocket. Okay, we just missed that one. Now let us go for the see all our satellite launch vehicles. The first SLV-3, it was launched on 10th of August 1939. It was a failure because there was some leakage in the red fuming nitric acid. It could not give the control and the rocket failed. And the second successful flight was a successful flight that was on 18th July 1980. Then ASLV, we have two failures in the first two flights. We get success only in the third and the fourth flight. Similarly, for the PSLV, the first flight was not at all, it was very successful in the sense it could not place the satellite in the orbit because of some guidance, some control system signs were not matching with the pitch up and pitch down. Then GSLV was the first flight, it was a successful flight, though it was happened on April 1821. Then GSLV Mar 3 on June 5th, 2017 was the first called LBM-3, where it was a dummy payload, and the second flight was having the full payload of 2,500, and it was launched. Then now the question arises: what is the principle of a rocket? How a rocket works? I thought student up to third, they must be knowing when they ignite the Diwali rocket, it goes up because some hot gases comes out and they give the thrust. And we know there are the two laws are there which are followed for the motion. That is called the Newton's third law of motion. For every action, there is an equal and opposite reaction. And the second law is law of conservation of the momentum. See, what are the energy we stored inside the rocket in the form of solid propellant, or the case may be of the liquid propellant, which is here. So in that, you will see that both liquid propellants are stored in two different chambers. So whatever the chemical is stored in the propellant, it is converted into the kinetic energy by burning inside the rocket chamber, and subsequent gases that goes out, it gives us that. This is the principle of a rocket. Whether it is a Diwali rocket or it is a major rocket, both principles are same there. Then the question arises, in a rocket, what are the major parts are there? So when you compare with our conventional Diwali rocket with our rocket, what ISRO uses here. So what are the major elements? There is a propulsion system, means where the stored chemical energy is converted into gas by combustion. In the Diwali rocket, there is a magnesium powder and the oxidizer mixed together and kept there. Then the comes very important comes in the navigation, guidance, and control, which is not there in that rocket. It goes on its own. It can hit anywhere wherever you want there. When you launch a rocket, you need a system. What you want to do? Suppose you want to put a satellite in the orbit, you will use a nose cone. You will keep the items here. If you want to make a destruction, that is a bomb, then the rocket name will be changed to missile because it is meant for the destruction. Then the major thing comes in the structural system. Means when the rocket goes in the atmosphere, the structure should be rigid. It should not break up with the forces acting on the rocket when it is ascending there. So there are the four major elements are there in the rocket: propulsion, navigation, guidance, and control, and payload system, and the structure. Now in the rocket propulsion, what are the main systems are available here, or we have expertise. When we say we mean the ISRO has expertise, we have expertise in the solid propellant.
Rajgopalanji, can you switch off your mic? It's creating disturbance, sir. Thank you,
Then,
sir. Thank you.
Sir, I will continue, sir. Then we have a liquid propulsion where the two liquids they combine together in a chamber and burns. This liquid can become called the earth storable, means these two liquids are in liquid form when they are in the atmosphere. Then we have a system called semi-cryogenic, means one of the propellant is in liquid form in the cryo form, that is the temperature is less than 150 degrees Celsius, and other is a liquid in the atmosphere. Then we have a cryogenic where both the liquids, solid, both the oxygen and fuel, they are in the liquid form and kept at the very low temperature. In case of hydrogen, we go as low as around 121 Kelvin. The oxygen goes around 68 Kelvin. Then the rockets are there called the hybrid, nuclear, solar, and ionic. These are the advanced rockets. Normally, ISRO doesn't, but now we are working on the nuclear, where you use in the satellite to give the guidance in the upper atmosphere. We have a mastery in the cryogenic. We have mastered in the orchestrable. We are mastered in the solid propellant. Now we are making in the semi-cryogenic, going to use kerosene or the white kerosene and the liquid oxygen. The tests are all in progress. I think when our students will become engineer, probably if they join in ISRO, they may get this particular system. Is in quite work is going on here. Now, what is the thrust? The thrust is when the gases comes out from a rocket nozzle, it gives the what you can say an opposite direction. Similarly, if you compare this is with the car, the car thrust is different than the our rocket thrust. Rocket thrust is a 1:1. Whatever the chemical engine you stored in the chamber, when you burn it, when the gases goes out, it will give the opposite direction, the thrust. Because car is slightly different. This I will explain in the next few slides. Now, next important is the navigation, guidance, and control system for a rocket here. Now, if you see the guidance system, there are two guidance systems are used. One is called the radio guidance, means we can give from the ground to the rocket where you have to go. One is called the inertial guidance, where the gyro computation controllers are there on board computer. They get on its own, and they. So now if you see a car, if somebody is sitting next to the driver, he will be giving guidance. You go to left, you go to right. So similarly for our rocket, time chart is everything should go in a auto mode, or you pre-program and load on the onboard computer at appropriate time, you will get it. Most of the things in the called the radio guidance, as the morning Kiran Kumar Saab was telling, we take around 18 minutes to send our command to Mars. Means we are sending through our message to the radio system, which are achieved after 18 minutes, and they'll give the guidance. Then these are the very quite advanced systems. I think our 10th class slightly will be difficult. So we'll go forward here. Like when you drive a car, you have a system where we can go left side, right side, reverse, forward. But for rocket, there are the three things only possible. When rocket goes, one is called the yaw, means it moves in the sideways. Either this side is the plus. If it is moved, this will be a negative side. If the rocket goes there, it can roll on its own axis. If it rotates, it is called rolling. And then when rocket goes up, it has to be pitched down. If it is in the positive side, the pitch. If it is goes up, it is called the pitch minus. So morning, some our orator something they were telling. So this rocket, when if it is not pitched down, if it goes vertical, it goes vertical up and up and lost in the universe. That's what morning he was telling. So this has to be given a particular direction. This means we have to pitch down. If the rocket has not followed is the path, that is this azimuth path, it has to be moved. Yeah. So like this, three things are possible. They're all controlled by the help of these exhaust gases, by the help of these fins. This is the only control, and all the subsequent flights, if you see here, there each rocket will have a different type of nozzles. If this nozzle called a gimbal nozzle, if it is going in the vertical direction, the rocket will go up. If you slightly rotate this, it will take the direction. It will change the direction, and wherever you want to go, it will go accordingly. If the rocket has taken a roll, start rolling, you have two sets of rocket, which will balance in such a will fire in such a way they will not allow the rocket to roll. Then we have some rockets will have a thrust vanes. These are the very typical types of just fundamentals I want to tell the students. Some people some students they ask the question how the rocket is maneuvered in the atmosphere. This is the methods by which we can steer the rocket according to the onboard computer's directions. Now I want to give a very small analogy between the car and the rocket. I think most of our students will be very happy to know what is the difference, what is the similarity between. See, car and rocket both are used for the transportation purpose. Car is used for the surface transportation, and the rocket is used for the space transportation. Now, propulsion both needs the fuel and the oxidizer. Here also, the engine needs oxidizer and fuel. So, as we go up above the atmosphere where oxygen is not there, this engine will not work. Where when we are carrying our own fuel and oxidizer, the system will work and the rocket will get the propulsion and it will move further. Then, as I told you, one of the most important point of a rocket is the structure. Now you see the body of a car. It is very rugged, very strong. Nothing will happen to rocket. And when you go for the structure of a rocket, the structure is so light. Every structure is optimized to such a level. Suppose it will fail at about 45 to 50 kg per centimeter square pressure. They will use up to 38 to 37%, 1.1 to 1.2 factor of safety. They will use the structure. The more the light the structure, we can have more the payload. If the structure is very strong, then payload will go down. This is a material which is developed for the stage first. There is a material called 15 CDV6. That material, it is so light and so strong compared to the ordinary steel. Then it comes the navigation. Navigation for the car is the human man. He sees physically left side, right side, and navigate. While in the rocketry, your navigation will be only through the computer because time is so short to take the decision. Similarly, for the guidance, in a car, guidance will be your next man who is sitting to the driver. He can give guidance. Here, all by computer. Then control. Controlling the car is very easy. You apply the brake, it will be under your control. But rocket, you cannot apply a brake. So you have to maneuver it to your required, we call it as steering. Then similarly, for the payload, here is the road transportation is moving the people from one place to another place. The human. In this payload, we are using the satellite from to the orbit. Now we are going to put in the Gaganyaan human as in the inside the capsule to move around the system. So this I just want to give to students one analogy so they can easily compare between the rocket and the car movement. Now the PSLV rocket has some, this I will skip it. This is quite, now the orbit morning itself, I think a lot of our friends has given about the orbit. So this also I will skip. I will show only one orbit from here. Yeah, one question was there. What is a GTO? Some of our friend was asking what is geosynchronous orbit. So this is the when the satellite rotation it takes the same time what it takes the Earth. So that is called the geosynchronous. Now I just want to show what is the function of a rocket and what is the function of a satellite. This is a very typical question somebody asked, what is the GTO? In the morning when I was reading the chat box, some student, he didn't give his name, but his curiosity was to know about the GTO. So when the rocket is launched, this is a rocket of GSLV. When it lifts off from 0 to 170 kilometer altitude, by the time all the rockets stages, all the fuel would have been burned out, and nothing will be left there except the satellite. So in the next slide, if you see here, the satellite is injected in the GTO, means the nearest to orbit to the farthest to orbit. This will be depending on the capacity of our rocket, will be from 170 to 200 to farthest point in order about 28,000 to 35,000. We will put in this highly elliptical orbit. So the function of the GSLV is over. Now the function is with the satellite. The satellite is having his own fuel. It is having his own oxidizer. It is having his own engine. One is the main engine. Then we'll have our 12 in the corners. Another micro engines, which give the thrust of the order about 1 Newton to 11 Newton. And the center main core is gives the thrust about 440 kilonewton. Now, after coming this one, immediately whatever the solar array was stored, they will be spread out. In the array deployment will take place, so that satellites come in the full motion to take the position, and they tell the position here. Now, after reaching here, the apogee motor fire a rocket of the liquid propellant bipropellant at this farthest point. It is fired in such a way it increases the elliptical orbit to another elliptical orbit. Now, after coming in the third apogee boost motor, certain figures are coming in the bottom. I am not able to read because of some other reasons. Now, like this, the aim is to make it a circular orbit. The time taken for this satellite to move in this, it should take around 24 hours. By the time the Earth also will take 20 hours to move here, means the antenna of the satellite and the Earth, they will be seeing each other.